Our first application of de Moivre's theorem, his theorem, is going to be looking at sine, oh, I haven't got a pen on, sine 4 theta. Now, let's say I'm not in the mood for multiple angles, don't like it, don't like that 4 theta, I just want thetas. I don't care if I've got sines or coses or powers, I just want thetas, don't like it. So, this is what we're going to do. We're going to start with cos theta plus I sine theta. And we're going to have that all to the power of 4. Okay, so using the formula of de Moivre, that is cos 4 theta plus I sine 4 theta. So far, not very useful, you might be thinking. But hang on, I could have done the binomial expansion on this, couldn't I? I know the binomial expansion. Power of 4, that's not really that big a number. So if I do the binomial expansion, what would I get? I would get, hope I've got room, cos to the 4 theta plus 4 cos theta I sine theta. That one would be cubed. Plus 14641. 146, oops, forgotten Pascal's triangle momentarily. 1331. 14641, that's right. 14641. So 146 of these. And then 4 of these. And then 1 of these. I sine theta to the 4. Okay, now that is the binomial expansion of this, so that must equal cos 4 theta plus I sine 4 theta. Still probably you're thinking, so what? But anyway, let's just go with this. Let's tidy it up a bit. Cos 4 theta plus 4I cos cubed theta sine theta plus, now what have I got here? Actually, I'm not sure I've got a plus because I've got this I squared. So I squared, that's minus 1. So actually I've got a minus there. Minus 6 cos squared sine plus, minus, plus, what have I got? I cubed. So that's I times I times I. I times I is minus 1. So minus I altogether. So it'll be minus 4I cos sine cubed plus or minus, I think I've got an I to the 4, so that's I times I times I times I, which is minus 1 times minus 1, which is plus 1, so plus sine to the 4. Okay, let's organise that into real and imaginary. Cos to the 4 theta, that's real, that's imaginary, this is real, minus 6 cos squared theta sine theta, and this bit on the end is real, plus sine to the 4 theta, plus, there's the real bits, I, 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. You're probably still thinking, so what? But look, this thing here to the 4 is equal to this, which is equal to this, which is equal to this. This is something real plus I, something imaginary, but it's also, by de Moivre's theorem, equal to this. Real bit plus I imaginary bit, real bit plus I imaginary bit. So if we've got a complex number, real plus I imaginary, real, and it equals another complex number, real plus I imaginary, then it must be that the real part equals the real part and the imaginary part equals the imaginary part. So, in particular, since I was interested in sine 4 theta, sine 4 theta must equal all of this. I don't think I can get rid of that Pascal's triangle now I've drawn it, but anyway, sine 4 theta is equal to 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. Now actually, I got another result accidentally in this. I got the red result. So I actually also accidentally found out that cos 4 theta is cos to the 4 theta minus 6 cos squared theta sine theta plus sine to the 4 theta. I also found that out. Not that I was particularly interested in it, but I found it out. So actually, if I'd been starting with this, saying what's cos 4 theta, I don't like this multiple angle, I'm not in the mood for multiple angles today, I want powers but I want single thetas here, just single angles, that's what I'm in the mood for today, then I would have started the same way. Cos theta beside sine theta to the 4, using de Moivre as cos 4 theta beside sine 4 theta, and using the binomial expansion is this. So the real bits of the binomial expansion are what cos 4 theta is, and the imaginary bits of the binomial expansion are what sine 4 theta is. So I get 2 for the price of 1 method there. And that is our first useful thing that de Moivre can do if you've got sine or cos and you've got multiple angles, but you're not in the mood for multiple angles, you're in the mood for powers of single angles, then this is what you want to do. You want to go de Moivre, binomial, real is real, imaginary, imaginary. Good.